Hey everyone, my name is Julius Pisecki, and I work at Columbia University in New York. I'm an oceanographer and climate scientist. Today I'm here in my role as a Pangeo member and a maintainer of the CMIP6 cloud data. I will mostly try to get you excited about working with CMIP6 data in the cloud. And to do so, I will look at what is needed to produce a plot like this. What I'm showing here is a global average sea surface temperature from the latest IPCC report. But how exactly does one get a graph like this? A typical workflow might look something like this. You download the data, then clean it up if needed, more on that in a second, and you then apply some custom analysis to it and interpret the results. However, increasing data science and size, and CMIP6 really is big, means that downloading and duplicating even sort of a small amount of the repository is becoming increasingly expensive and time-consuming, especially. And really, only rich institutions like my employer, Columbia, can afford to just duplicate the data and make it available to people in a fast fashion. This effectively limits the participation in the climate discourse to people who work at such affluent institutions. I truly believe that to accelerate science, we need as many hands on deck as possible. And really, we need to turn this pyramid around. The way we have done this with Pangeo starts with the data. We ingested over 100,000 of data sets into publicly accessible cloud storage and opt to bring the compute to the data rather than the other way around. What does that mean? Let's take a quick look at this graphic. If you opt to download the data, you need to bring all of the raw data over a possibly slow internet connection to your lab or laptop or wherever you're working. Over there, you have a fast connection. You can visualize that data, but you have to wait for all of that data. If instead we bring the compute to the data, all of a sudden a slow internet connection is not that big of a deal anymore. All that is sent over the internet are your commands and figures that you get back or other visualizations. The heavy lifting really is done in the cloud with super fast internal connections and scalable machines. And maybe most importantly, now it is really trivial for others to work with the same data in the same way. And you can much easier collaborate and focus on what matters: new ideas, collaborations, and great science. So that still leaves us at the step of data cleaning. As with most data sets, cleaning the data is really a vital part of CMIP6 analysis. Like common issues are differently named dimensions, unit problems, and other small issues that slow down a scientific workflow where you could want to compare different data sets. But once these are found, they're actually fairly easy to correct on the fly. And so in the past, I developed XMIP as a way to crowdsource these common fixes so they don't have to re-implement them every time you experience a new data set. I really would love for everyone to give it a try and let me know if they find any new issues and sort of build that knowledge base of fixable errors. Very important to mention here, even though it is really nice to work with XMIP in the cloud, as most of the Pangeo software stack, it doesn't require you to run it in the cloud. It runs just well on your laptop on a server, as long as you use Xarray to load the data. In longer presentations, I usually run a live demo to show you that we can reproduce the plot from the first slide within about 2 to 5 or 2 to 10 minutes, depending on what machine you're running on, by using the analysis-ready cloud optimized data. But since this video is very short, you will have to believe me that the sped up video I'm showing here is not actually fake. To confirm that, you can go to the repository and either run the code yourself or check out my longer talk recording that I gave at SciPy. Additionally, you might find it interesting to read the blog post I wrote with my colleague Tom Nicholas. And really, the one thing I'm really excited about this year is that you can now reproduce this important scientific finding in really the time it takes you usually to brew a coffee. Compare that to the traditional workflow where you would have spent hours and days sorry, to just download the data. You have so much more time to do science now. Well, you can clearly tell that I'm extremely excited for this cloud data and working with it, but I really believe that it's not just me. I've gotten some really amazing feedback over the past months and past year. And I've talked to many folks who actually never used CMIP6 data before because it was so complicated. And they started using it and sort of incorporating it into their science and their proposals just because it was easy to just take a look. And I really think that getting feedback like this is a huge motivator for me to like keep doing the work that we're doing, and really getting us to that goal of getting more people involved in climate science. I truly believe that open science is the way to accelerate climate science to sort of meet the needs of the global society to tackle the problem of man-made climate change. And I think this is a great way towards that. Well, if you have any questions, please reach out on GitHub or Mastodon. And I wish you all a very wonderful conference. I'm very sad I couldn't be there, but hope you all have a great time.